Today we are going to talk about proving triangles congruent. And over the course of the chapter, we're going to learn a couple different ways to do that. Okay, so we're going to learn actually what shortcuts there are to prove that triangles are congruent. So in order to prove that these two triangles are congruent, you have to prove a lot of things. You have to think about, what does it mean for triangles to be congruent? Well, first it means that all of their angles are congruent. So up until this point, with the lesson from yesterday, you would have to prove that angle A is congruent to angle F, angle B is congruent to angle E, and angle C is congruent to angle D. And that's not enough. Then you would have to prove that all of the corresponding sides are congruent. So remember, we talked about congruent sides in the video yesterday. So AB goes with FE, BC goes with ED, and then AC goes with FD. So it's important that you have that congruence statement and that you know what your corresponding parts are. Now, there are shortcuts in order to do this. We call them shortcuts because here we only have to prove 3 things are congruent as opposed to 6. And this is what we call the side angle side theorem. If 2 sides in their included angle on a triangle are congruent to 2 sides and their included angle on another triangle, then the triangles are congruent. And we abbreviate that with side angle side, or SAS. So what does that mean? In this case, it would mean that AC is congruent to EF. Okay. And notice that I'm trying to keep the order the same, right? A is this outside, E is that outside. And then if I go for the other side, CB is congruent to FD. So I have one side, I've got this side, and then I have an angle. Angle C is congruent to angle F. And it's important that it's this included angle. Okay. Once we've got those things proved, then we can say that the triangle is congruent. It's going to make it rigid. It's not going to move, basically. So just to be sure, what's an included angle? So what an included angle is, if I have this side, FE, and this side, FD, the included angle is going to be that angle F. So it's basically the vertex of the 2 sides that make up an angle. Okay? If I have this side and this side, then it is this angle right here that's included. It's the angle that makes up the vertex. And that's going to be important. So let's decide whether we have enough information to prove the triangles are congruent. And if there is, we're going to state the postulate or theorem, and I'm actually going to have you write the congruent statement because that's an important thing too. So when I look at this, okay, I have a side congruent to a side. So I've got that MN is congruent to, and I'm going to go with this side, OL. Okay. I've got that this angle is congruent to this angle. Now, because I've got a whole bunch of different angles, remember, I've got to stay that I've got to use the 3 letters. So OMN is congruent to, so OMN is congruent to ML. So MOL. So notice I've got that congruent is this right in the middle. Okay, now it looks like I don't have anything else, but we talked about in earlier chapters the reflexive property, and you all were like, that doesn't make sense. Why do we have to know what that is? Well, now we know what that is. We can use it in proofs. So we say that MO is congruent to OM by the reflexive property. Okay, so there is enough information to say that this is congruent, and it's congruent by side angle side. So we can take this angle, the angle OMN, and make it a triangle and just say, there's my congruent statement, that those triangles are congruent. Now let's look at this second example. Remember that these mean that these lines are parallel, right? So I've got this angle, got that Z, so that means that this is congruent to this. Okay. All right. So I've got those congruences. I'm going to erase and I'm going to highlight them so that you can see. Okay, this and this are congruent. I've got this angle, or this side and this side. Okay. And then I have this side by reflexive. But what I want you to notice is that there is not enough information because this angle is not included into the two congruent sides. That angle is not included in between those two congruent sides. So in this case, we can say that there is not enough information. So hopefully you see the difference between an included angle. So this angle was included between that side. And then this angle was included in there. So yes, we have proofs. Right? So if I have QP, that side bisecting RQS. So here's RQS, and that's bisecting that. Okay, now when you're doing a proof, you want to look at what your end goal is, and our end goal is to prove those triangles are congruent. Okay, so the QP bisecting that is our given. Okay, bisecting, remember, means that it cuts it in half, right? So that means that this angle and this angle are congruent. So right now, I've got this angle congruent to this angle. And that is angle RQP congruent to angle SQP. And that's by definition of an angle bisector. Okay, that definition says that if something bisects an angle, it cuts it into two congruent parts. So I've got that. So I've got this angle. Then I've got side QR is congruent to QS. So I've got this congruent to this. That's what we're given. And now we need the side. So we've got this angle. We've got this side there. It makes up that angle. So that means I need this to be congruent. It's congruent to itself. So we're going to go with QP. Oops. Congruent to itself, to QP, and that's by reflexive. This is given. So now I've got a side, an angle aside. a side, an angle, and a side. So I can say that those are congruent. Triangle RQP is congruent to triangle SQP, and that's by side, angle, side congruence. Okay. All right, so notice I just took it step by step, thought about what do I need. Right now, all you're going to need is a side and an angle side, and that angle has to be included. Okay, so here's another proof. I've got B is the midpoint of AD, so here's B, it's the midpoint of this whole side. And then I've got angle ABC and DBC are right angles according to the diagram. Okay. So I'm going to start with B. I'm proving the triangles are congruent. So if I know B is the midpoint of AD, that's given. Midpoint means it cuts a segment in half, so AB is congruent to BD by definition of midpoint. Okay. So now I've got a side. Now I've got these right angles. Angle ABC and angle DBC are right angles. That's also given. We get a theorem that says that all right angles are congruent, so we're going to say that they're congruent. DBC. And that is all right angles are congruent. Okay. So now I've got a side, I've got this angle, and now I need my other side, and here comes our friend, the reflexive property. CB is congruent to CB, okay, and that's by reflexive. And so now I've got my side, my angle, and my side, my side, my angle, and my side. So I can say that the triangles are congruent. Okay, by side, angle, side. Congruence. Now, because we know that all right angles are congruent, the side angle side can also be called, and only used in right triangles, what we call. So today we learned that we could prove triangles congruent by side angle side, proving that two sides and the included angle of one triangle is congruent to two sides, and the included angle of another triangle will prove that they're congruent. Have a mathtastic day.